This is James Manning. I'm with Hunsaker & Associates in the Irvine office, and we worked on a project where the client asked us to do modeling of things as we went along, and it's worked out quite well. We've had to develop tools to make all this happen in an efficient manner, and through our tools we've generated 3D solids and then 3D break lines to use to make surfaces. So I'm actually in Civil 3D 2012 here, and I'm on a 64-bit machine, so it's got enough memory to handle all the stuff that I'm showing right here. There's a lot of stuff, but let me kind of get in here and orbit around a little bit. Let me see if I can get this thing centered. Okay, orbit around a little bit and show some of the features. So, all right, so as I roll in, get a little closer, you can start to see more of the detail. Hopefully this looks okay in the final video, but you can see that we have storm drain, sewer, reclaimed water is purple, domestic water is kind of the cyan color, and I've got slopes modeled in here, trees, and lots and lots of different utilities. So as I get in close, you can see that we've modeled even the air vacs and blow-offs. There's a cathodic test station there. And some of the colors I haven't really tweaked to be perfect right now, but this is our joint trench right here for dry utilities. Our dry utility trenches are modeled as rectangular, and the wet utilities and actually gas are modeled as circular. So you can pretty quickly look at this without seeing a bunch of text that shows what it is and figure it out. So let me walk over to one of our entrance streets. So you would turn here and come down this street, and you can see the trees that we got. And all this stuff is actually quite easy to produce once you have the tools kind of to do it. I mean, the hardest part of the whole thing is making the surface, and that just takes a bit of time because you have to have your design input into horizontal and vertical alignments. And then for things like roundabouts, you're going to be taking the detailed design that's been done by whoever, the rough graders or final street designers. And you can enter those elevations and explain to the computer what's going on with the 2D feature, you know, where are the elevations along it, and it interpolates in between, and then you apply sections and it moves those around, and as anything updates, you just update the information and it updates the 3D line work. That's how our tools are set up. It's a bit different than how, let's say, Autodesk corridors do things, but we found it to be really efficient, and we use it in production. So let me go over to some other areas here. So here was a bridge going across a creek, and we modeled this with a top surface and a bottom surface, and we did the piers and everything and all the abutment. Oh, start to get a lot of stuff going on. It kicks over to wireframe mode there. And we actually do utility conflict detection off of this. There's a real crowded area over here with a lot of water appurtenances. And we check to make sure that the fire hydrants, which is this guy right here, and let's say air vacs and test stations and things, their actual footprint fits on the sidewalk. Because on a plan, you know, an air vac might look like a little triangle or a circle for a blow-off, but when you actually start drawing out the laterals and what the copper pipe's going to look like, more or less, because it is flexible, you discover it. Sometimes these things take up more area than you expected, and you have dry utilities to contend with. So got a lot of stuff going on. There's actually a pressure reducing station over here. So these gray, they look like walls underground. That's our dry utility trench, and actually probably it conflicts with our wet utilities in a lot of places currently, and that's because they know to go under or over or around those. We haven't actually modeled how the conclusion of that is going to be, you know, which goes under what and what moves around, but usually it's the dries moving around because the wets have already been through submittal, and so you'll see a lot of dries crossing wets or storm drain in this sense, but you won't see any of the wets crossing anything else, because that's been all coordinated and plan and profile done. And it's a really wonderful tool when you can talk to somebody and show them, say, here's what the utilities are doing in this area. Sewer's going under storm drain. You got a little bypass going on the storm drain, and a basin, say, over on this side. Let me pan over a little bit. Yeah, so a little water quality basin here. And let's go over to the entrance. This is actually pretty interesting design, because it's got roundabouts steering people around the intersections instead of a lot of signalization. So it's a modern trend. Hopefully it all works out in the end, because those can be interesting driving around. So but you can see we've got our V-ditches here, and when these get modeled, you only model one side of them, then you have a section that gets applied, and it does the 3D offsets, and most of the stuff that looks difficult isn't that difficult, and a lot of the stuff that looks simple is actually, there's a lot of handwork involved, because there's nothing that drives it. There's no profile, there's no horizontal alignment, it's kind of just free form, and that takes a little bit more effort to do, but it's still relatively easy. And I'll zoom out a little bit. You can see our existing ground is in brown there. So, we use our own tools to do a lot of different stuff, but these surfaces are all done with Civil 3D. We pull the line work in, and they've worked just beautifully. I mean, the surface functionality of Civil 3D is just really, really nice to work with. So no matter how you approach it, you still have a foundational product going there, and there's some different vaults and things. We had clearance areas shown on these where you couldn't put trees and things on different stuff. So thanks for watching.